Welcome to the DIY Honda Garage channel. This presentation addresses the Diagnostic Trouble Code, DTC P0722, which pertains to the output shaft countershaft speed sensor, indicating a no-signal input error. This issue primarily involves the electrical circuitry associated with the sensor, rather than any mechanical faults in the vehicle's transmission. The Honda Pilot, manufactured between 2016 and 2022, is equipped with advanced systems where the proper functioning of the speed sensor is crucial for optimal driving performance. When this DTC is triggered, it may affect the overall transmission efficiency, leading to performance issues. Understanding the role of the output shaft speed sensor is vital. It measures the rotational speed of the output shaft, sending crucial data to the Powertrain Control Module, PCM, for operational adjustments. This guide will provide a thorough breakdown of the error, its causes, symptoms, and detailed troubleshooting procedures. The DTC P0722 indicates a malfunction with the output shaft countershaft speed sensor, which is responsible for sending rotational speed data of the output shaft to the Powertrain Control Module, PCM. The sensor is located within the transmission assembly, typically on the transmission housing, making it crucial for monitoring vehicle speed. The role of this sensor is pivotal for ensuring that the electronic control unit accurately determines shift points and performance adjustments. When the sensor fails to send a signal, it can lead to various transmission issues that impair the vehicle's performance. Notably, this error is flagged as an electronic circuit problem and is not associated with mechanical failures within the transmission itself. Therefore, it is essential to focus on the sensor's electrical connections and associated wiring during troubleshooting. The causes of the DTC P0722 can be primarily attributed to issues within the electrical circuit connected to the output shaft speed sensor. A common source of trouble is poor electrical connections, often stemming from corrosion, dirt, or wear and tear over time. Loose terminals in the wiring harness can also disrupt the signal sent to the PCM, leading to inaccuracies in speed measurement. It is essential to confirm that all connectors and wiring harnesses are securely attached and functioning properly. It should be noted that this code does not arise from mechanical failures within the transmission system, which simplifies the diagnostic process. These root causes emphasize the significance of proactive checks on electrical components during vehicle maintenance. Several symptoms are associated with the triggering of DTC P0722, all of which stem from the failure of the output shaft speed sensor. One of the most noticeable symptoms is the illumination of the check engine light on the dashboard, prompting the need for diagnostics. Drivers may also experience erratic acceleration and performance issues in the transmission, such as slipping or failure to shift seamlessly. Additionally, inaccurate speed readings will likely occur, affecting the vehicle's overall control. These symptoms can lead to a degraded driving experience, emphasizing the importance of addressing the DTC promptly. Although the transmission may still function, it may not operate as optimally, leading to potential long-term damage if left unchecked. The first step in troubleshooting DTC P0722 begins with verification of the problem by turning the vehicle to on mode, allowing for the initialization of vehicle systems. Utilizing the Honda Diagnostic System HDS, clear the stored DTC, which assists in obtaining an accurate assessment during future tests. Subsequently, raise the vehicle securely on a lift to ensure that it is stable and can be operated safely during diagnostics. While the vehicle is elevated, the next step involves starting the engine and disabling the Vehicle Stability Assist (VSA) system by pressing the VSA off button. This is a critical step as maintenance mode for the VSA is required if the vehicle speed is above 31 miles per hour, 50 kilometers per hour. Maintaining a speed of over 12 miles per hour, 20 kilometers per hour, allows for a comparison of the input shaft speed and output shaft speed, which provides key data for further identifying the root cause of the error. For the second troubleshooting step, begin by turning the vehicle to the off-lock mode to ensure safety while working on the electrical system. Disconnect the output shaft, countershaft, speed sensor 3P connector, which is critical for isolating the sensor from the PCM. Next, switch the vehicle back to on mode to exert power through the electrical circuits. By measuring the voltage between test points 1 and 2 at the sensor connector, you can ascertain whether approximately 5 volts is present. Conduct this test under the conditions stipulated, specifically with the output shaft speed sensor connector disconnected, ensuring an accurate reading without interference. If the voltage is at the expected level, the VCC1 wire, responsible for carrying this voltage, is confirmed operational and you may proceed to the next step. However, if voltage is absent, you must address the open circuit issue in the VCC1 wire, which runs between the speed sensor and the PCM. In the third step of troubleshooting, you will again measure the voltage between 2 specific test points with the output shaft speed sensor connector still disconnected. This step focuses on the NC line, which is an important part of the sensor assembly. The conditions remain the same as in the previous step, whereby the vehicle is in on mode and the sensor remains disconnected. This ensures that you are testing the correct electrical pathways without any interference. The measurement should be taken between test point 1, connector number 2 of the speed sensor, and test point 2, body ground. Confirmation of approximately 5 volts at this stage indicates that the circuit is intact, allowing you to advance in the diagnostic process. If the voltage is not present, there may be other underlying issues that need to be explored further, thus directing you to Step 5 to assess connections and repairs. Step 4 focuses on checking for continuity within the SG1 line. Begin by turning the vehicle to the off-lock mode to safely perform this connection test. With the output shaft speed sensor 3P connector still disconnected, you will need to check for continuity between test points 1 and 2. In this case, test point 1 is located at the sensor's number 1 pin, while test point 2 is again at body ground. Establishing continuity at this stage confirms that the SG1 wire is functioning correctly, which is essential for the proper relay of signals to the PCM. If continuity is detected, the SG1 wire is validated and the troubleshooting will move to replacing the output shaft speed sensor itself in the following step. Conversely, if the test yields no continuity, it indicates a fault in the SG1 line, necessitating repairs in the wiring leading to the PCM. The final troubleshooting step involves checking for potential short circuits within the NC wire. Start by ensuring the vehicle is in the off-lock mode for safety before proceeding. Activate the SCS, Supplemental Restraint System, line with the HDS to facilitate accurate testing, and allow a minimum waiting time of 1 minute for the system to be ready. Afterward, disconnect the PCM connector C51P to isolate the electronic control unit from the system. A continuity test will then be conducted between test points 1 and 2, which checks the path from the output shaft speed sensor to the PCM. If continuity exists at this stage, it indicates that a short to ground is present within the NC wire, which needs immediate repair. Conversely, if there is no continuity, it implies that there is an open circuit in the NC wire requiring attention to ensure complete functionality of the output shaft speed sensor. Once all necessary repairs have been completed for the DTC P0722, it is crucial to verify their effectiveness through a structured, final repair verification process. Begin by clearing any DTC codes from the vehicle's system to reset diagnostic functions. After performing repairs, taking the vehicle for a road test is essential to monitor its performance under real-world conditions. During this test, pay attention to the vehicle's shifting and acceleration to ensure that they are functioning smoothly without any discrepancies. Post-road test, recheck the onboard diagnostic system for the reappearance of the DTC, ensuring it remains cleared after repairs. This final step validates that the troubleshooting and repair processes were successful, confirming the vehicle's wiring and sensor are functioning optimally. Preventive maintenance plays a vital role in avoiding issues like the DTC P0722 in the future. One of the best practices is to regularly inspect the output shaft speed sensor connections and wiring harness for signs of wear, corrosion, or loose contacts. Cleaning the electrical terminals and contacts can help prevent poor connections that lead to erratic sensor readings. Furthermore, checking the integrity of the wiring insulation is crucial in protecting internal circuits from moisture and wear over time. Keeping these connections clean and securely fastened mitigates the risk of intermittent failures in the electrical circuit. Lastly, being proactive with routine diagnostics and vehicle maintenance will significantly extend the reliability of the transmission system, promoting overall vehicle longevity. In summary, the DTC P0722 is indicative of a failure in the output shaft speed sensor, and it specifically highlights an associated electrical issue rather than a mechanical one within the transmission. The troubleshooting procedures outlined emphasize the importance of checking connections, testing wires, and verifying electrical pathways to isolate and resolve this issue. By understanding that the problem is usually rooted in poor connections or faulty wiring, technicians can conduct focused diagnostics, which can save both time and cost. Routine vehicle checks, along with preventive maintenance strategies, can significantly enhance transmission performance and prevent recurrence of this error. Maintaining the electrical integrity of the output shaft speed sensor ensures optimal communication with the PCM, leading to smoother driving experiences. Ultimately, addressing DTC P0722 not only reestablishes functionality, but also contributes to the vehicle's overall safety and reliability. Please like and subscribe to the channel. See you next time.